Hi guys, we're going to continue with our discussion of coordinate proof, and I just wanted to put a few things out there very specifically with what we need to be doing. And the first thing we've got to make sure we focus on is just what is it that we're trying to prove. So if I say I'm proving something is a rectangle, then I need to make sure I can identify what makes something a rectangle. Four right angles, right? What makes something a parallelogram? The fact that opposite sides are parallel. You have to identify exactly what you're trying to prove before you do any work. And then you can get on your way. So I want to make sure I'm clear about what I'm expecting when I'm grading a proof. First, you need to complete any calculations or computations and state clearly what they're representing. Okay, so for instance, this is where we're going to be talking about slopes and distances, pretty simply. Right? And it all depends on that beginning part. What is it I need to show? Slopes are going to tell us two things generally. That sides are parallel. Whoa, sorry about that, guys. Sorry, so one thing is that sides are parallel, and the other is that sides are perpendicular. That's the two things that slopes can tell us. Distances are going to tell us usually that sides are congruent. And generally, those are the big things we're going to be focusing on. And so that kind of already brings us to the second point, is what is the implication of these. So technically, first off, you're just finding slopes and distances or whatever, and you're stating exactly what they are. Second is you take what you've noticed from those and make these decisions. So this is where you would say something like, oh, the slopes are equal, and that means the sides are parallel, right? Or you could say the slopes are opposite reciprocals, so the sides are perpendicular, whatever. And then third is taking this statement about sides or lengths or whatever, and then taking that specifically to the figure we're trying to prove. This is where you'd say, okay, opposite sides are parallel. That means we have a parallelogram, right? Or I have congruent sides, so it's a rhombus, or whatever it is I was trying to prove. But you need to state specifically, one, what were the calculations? What do those calculations mean about specific parts of these figures? And then what do those parts tell us about what type of figure it is in the first place? So I want to look at one more example. Okay, so this time we're asking to prove that this figure is a square. And if you want, try it real quick and pause it right now and do the problem, and then check and see if you do what I did. Okay, so I went ahead and drew the figure. And so again, I first need to identify what is a square. A square has two main properties. One is that there are four right angles, and two, that there are four congruent sides. So this is going to give me an idea of where I need to start. So first, if I want to show right angles, I'm going to have to find slopes. And second, if I want to show congruent sides, I'm going to have to find distances. So I'm going to need to do all of those things. Right? So first, maybe say I want to find the slope of PQ, slope of QR, slope of RS, and slope of PS. Okay, and so the slope of PQ, we can see it's 4 minus 0 over 0 minus 1 is negative 4. And I'm going to kind of do this more quickly. You can come and check with me. For QR, I'm going up 1 and over 4. For RS, again, it's negative 4. And for PS, it's 1/4. Okay, so hopefully you can already see some relationships going on here. But we still need to do, the order of those top three steps don't matter. So if you want right now, you can say PQ is perpendicular to QR, QR is perpendicular to RS, RS is perpendicular to PS, and PS is perpendicular to PQ, all because, right, the slopes are opposite reciprocals. We can do that right now if you want, instead of waiting to the end. Okay, and so this could kind of already hint at this over here, right? And if you want, you could continue and say, okay, this means there are four right angles. Okay, and now I'm going to need to say something about these distances, because right now I've already proven basically that it's a rectangle. So I'm going to erase this and then do our side. Okay, so we want to find the length of each one of these sides. Notice that I'm not writing the segment sign on top, because that means segment. Without that symbol, we're actually finding the length. This means the length of the segment, or distance between these 2 points. So the distance between P and Q is 1 squared plus 4 squared, which is the square root of 17. Difference between Q and R, the difference between 0 and 4 is 4. The difference between 4 and 5 is 1, and I'm getting square root of 17. For RS, from 4 to 5 is 1, from 5 to 1 is 4, and I'm getting square root of 17. And for PS, 5 to 1 is 4, and 1 to 0 is 1, and I'm getting the square root of 17. So now I can say PS is congruent to QR, is congruent to RS, is congruent to PS. So I have 4 congruent sides. And now I'm ready for my conclusion, and I can say, since this figure PQRS has 4 right angles and 4 congruent sides, we know it must be a square. And I can be done. I'm finished my proof. So it's really important that you have all 3 of these aspects, that I'm very clear about all of the work I've done. I know exactly what it's representing. I tell me specifically what that means about the parts of this object, and then I make a statement in general about the object itself. Okay, so instead of doing another one like what we have been doing, if you want, please check the answer key on Schoology and check some of the ones we've already done together. But I want to try to skip to one more, kind of the next step to this idea. So what if I want to prove something about all figures instead of just one specific one? We've been taking specific coordinates and saying, prove that these are the coordinates that belong to a certain type of object. But what if I think that all of a certain type of object have a certain property? Because it's really the same process with just one thing different in the beginning. Here, it's very clear what I want to show. I'm going to, at some point, have rectangles, and I want to show that their diagonals are congruent, meaning I'm going to have to do what? I'm going to have to find distances, right? And hopefully they'll be the same. So the new thing is, what are the coordinates? How do I define coordinates that make a rectangle for a fact, and that could be any rectangle, not just a specific length or specific lengths? And the key is that we use variables as our coordinates, right? So the nice thing about the xy plane is that we already know that x-axis and y-axis are perpendicular, so we can use that to form our right angles. If I go straight up and straight over, then I know I'm going to have a rectangle. So I can call this point over here whatever I want. Give me just a letter that could be anything, like for instance A0. And I can call this 0B. Why do I not want this to be 0A? If I called this 0A, then I would be saying A, even though A can be any number, A is always the same number. And that would make this length here the same as this length here, which would be talking about a square, not a rectangle. And I don't want to be too exact. So instead, I'm just picking a different letter. And I hope you can see this already automatically forms a right angle here. So I need to have a point here that's directly above A and directly horizontal from B, which means it has the same x-coordinate as A and the same y-coordinate as B, which would be AB. I hope you can see that this ensures that these are all right angles, right? This is a vertical line and a vertical line, and this is a horizontal and a horizontal line. Okay, so now we can go on with the proof. Oops, excuse me. At this point, the hard part is over, right? I have a rectangle. The length of this side is A, right? The length of this side is B. The length of this side is A. The length of this side is B. If I try to find slopes, the slope of this top side up here is obviously 0. And the slope of this is a vertical line, so we know they're perpendicular. So next, all I need to do is find the distance, the length of these diagonals. So real quick, I'm going to name these points. Let's say I call this point A and B and C and D. And let me get rid of some of these scribbles. Okay, so now I've got my rectangle. All I need to do is find out what is the length of BD. Well, Pythagorean theorem, distance formula, tells me what's the change in x from 0b to a0. Well, a minus 0 is a squared, And what's the difference between 0 and b? Well, it's b squared. So the length of BD is the square root of a squared plus b squared. And we don't have to simplify it any more than that. I mean, we can't, in fact. We cannot break this up. What about the length of AC? Well, from 0 to A is how far? It's A. How far is it from 0 to B? It's B. So now I have shown these two are the same length. So I know for a fact the distance for AC is the same as the distance BD. I can say that these segments are congruent. And I have proven that for a general rectangle, you could try this for any number. If this were A were 2 and B were 4, or A were 632 and B were 400, try them. Try it right now. Do your distance formula and check it. The diagonals are always congruent. Okay, the diagonals are congruent for all rectangles is what I've just shown, and we're done. Hope this has made some sense, and we'll talk to you tomorrow.